Hello, my name is Victoria Reed, and I am with the Carl and Melinda Hellwig Department of Biological and Agricultural Engineering at Kansas State University. Today, I will be presenting about the chemical, biological, and physical drivers that lead to harmful blue-green algae blooms in Kansas reservoirs. A little bit of an introduction is that blue-green algae, which is also known as cyanobacteria, have been a threat to Kansas lakes and reservoirs for many, many decades. And whenever these cyanobacteria bloom, they release harmful toxins into the surrounding environment that can be very harmful to both human health and to fish, even leading to major fish kills. There are many drivers that are known to lead to an increase in blooms, but then many of the drivers are still unknown. And so this study analyzes the long-term data from Kansas reservoirs to characterize water quality conditions, including blue-green algae, and we look at these by regions and different environmental conditions. My two main objectives were to study the chemical, biological, and physical parameters that lead to cyanobacterial blooms and to evaluate how those parameters correlate or if there's any correlation at all. To do this, I began with a literature review and I examined previously produced literature to establish a basis for this research and to be sure that we weren't repeating research that had already been done. Next, I began the data analysis phase where I was given 3 decades of water quality data from the Kansas Department of Health and Environment, also known as the KDHE. And then I used the software JUMP, abbreviated GAMP, to run correlation analyses and distribution analyses on many different water chemical, biological, and physical parameters. Whenever running these tests, we did split up the data by region in Kansas. And so from figure 1, you can see the 5 different regions. We did this to be sure to account for the different environmental conditions that vary throughout the state of Kansas. In figure 2, you can see the blue-green cell count compared to the total nitrogen and total phosphorus ratio by region. In figure 3, you can see the blue-green cell count compared to the trophic status index of each region. And then in figure 4, you can see the blue-green cell count compared to the age of the lakes for each region. And age of lake is how old the lake was when it was sampled. Figure 5 and 6 are photos I took this summer of cyanobacterial blooms in June at Marion Reservoir in Marion, Kansas. So in conclusion, there are many drivers that correlate to an increase in cyanobacteria blooms, including an increase in temperature, an increase in the trophic status index as shown in figure 3, and many other factors. But some of these drivers are still unknown. And so we will continue the analysis of this Kansas reservoir data set to examine the water quality trends over time and in relation to other land use and environmental factors. Thank you guys for listening to my presentation, and be sure to stop by and see me at the actual conference. And if you need any more information, my email is vkreed01@ksu.edu. Thank you.